everyone. In this video, we're going to look at the graphs of sine and cosine. So let's start with the graphs of our parent functions. And we're going to start with the graph of sine. So the first thing that I wanted to show you using a gizmo on explorelearning.com is that if we start with our unit circle and we rotate the terminal side of the angle one full revolution in the counterclockwise direction, then we get the graph of 1 period of sine. Now, notice when you look at this graph that along the x-axis, we have labeled the angles. Well, remember, the input for trig functions is the angle. And here the angles are in radians. And then the output is the ratio, okay? So the output, or the y-axis, basically is labeled so that you can plot the ratios. And remember, if you think of the ordered pairs around your unit circle, those represent the 6 trig ratios. Okay, so anyway, I just wanted to show you that as the terminal side of the angle rotates around the unit circle, and you can now follow the points on the graph of sine. If we rotate from 0 to 2 pi, we get what we call 1 period of the sine graph. Now, remember, if we rotate clockwise, that just creates a negative angle. So I'm just going to go backwards now. Okay, so our terminal side is back at 0, and now if I rotate the terminal side clockwise, we just get a negative angle. But again, as you follow the points, you can see 1 period of the sine graph. Okay, so here I'm just making the point that the graph of sine comes directly from our unit circle, and we can do the same thing with cosine. Let's get our terminal side back to 0. And again, if we take 1 full revolution counterclockwise, which results in positive angles, you can see how the point follows the path of the cosine graph from 0 to 2 pi. And then if we go back the other direction, which again just means the terminal side is now rotating clockwise, then we get our negative angles. Okay, so let's look a little bit closer at our parent functions. So first of all, trig functions are what we call periodic functions. And that just means that they repeat. Okay, so then you might ask the question, okay, well, how often do they repeat? Well, think about that 1 revolution around the unit circle. 1 full revolution is from 0 to 2 pi. So sine and cosine repeat their values every 2 pi. Okay, so that means sine of t, and remember t here represents an angle, would equal or be the same as sine of t plus 2n pi, where n is any integer. So that means that, like, if n equals 1, we're adding 2 pi. If n equals 2, we're adding 4 pi. If n equals 3, we're adding 6 pi. And n could also be negative. So if n is negative 1, we'd be adding negative 2 pi. If n is negative 2, we'd be adding negative 4 pi, and so on and so on. And the same thing is true for cosine. Cosine of t is equal to cosine of t plus 2n pi. Again, where n is any integer. Okay. All right, so let's start with the graph of sine. So this is the parent function. And in this graph, because sine is graphed from negative 4 pi to 4 pi, you're actually looking at 4 periods of the sine graph, okay? The period that we sketched, if let's say we went around the unit circle 1 revolution, then that period is represented right here. I'm just trying to trace over it. So this is 0 to 2 pi. This is 1 period of the sine graph. And then as you can see, that part of the graph is just repeated over and over to the right and to the left. Okay, so what is the domain of sine? Well, the domain of sine is all real numbers. The graph keeps going in both directions. So we'll say negative infinity to infinity. Okay, what is the range? Well, if you read the graph from bottom to top, you'll notice that your y values start at -1 and stop at +1. The period, as we've said, is 2 pi. Is the graph of this function even or odd, or is this an even or odd function based on its graph? And remember, that has to do with the symmetry of the graph. Graphs of even functions are symmetric with respect to the y-axis. Graphs of odd functions are symmetric with respect to the origin. Sine is actually an odd function because if we rotate the graph 180 degrees around the origin, we get the same graph. Okay, the y-intercept. Now notice that sine actually goes through the origin. So your y-intercept is 0, 0. Now the x-intercepts are actually infinite because as this graph keeps going from negative infinity to infinity, it repeatedly crosses the x-axis. So to identify the x-intercepts, we basically have to find a pattern, okay? So a way that we can represent our x-intercepts is we could start with the first one, which I'm just calling 0 because the graph goes through the origin. And then we can add and think about how often it repeats. So if you look at it, the graph crosses the x-axis at 0, 1 pi, 2 pi, 3 pi, 4 pi, basically every n pi. And again, where n is an integer, okay? So 0 plus n pi, we could also just put n pi. And you guys remember, at this point, n is understood to be an integer, okay? All right, let's look at the graph of cosine. So this is the graph of cosine. Again, very similar to the graph of sine, but there are a few differences. First of all, again, that 1 revolution from the unit circle, which represents 1 period, is actually represented right here from 0 to 2 pi. And again, that part of the graph is just repeated over and over to the right and to the left, creating the wave. So remember, the period is 2 pi. Now, the graph does continue in both directions forever. So our domain is negative infinity to infinity. The range, again, if you read the graph from bottom to top, our y values start at -1 and stop at 1. So notice that all of these characteristics are the same for both sine and cosine. But now let's get into some differences. So is cosine an even or an odd function? Cosine is actually an even function because the graph is symmetric with respect to the y-axis. If you reflect the graph over the y-axis, you get the same graph. Okay, the y-intercept is also different. The y-intercept for cosine is 0, 1. And the x-intercepts are different. So let's start with this x-intercept here, which would actually be pi over 2. So a way that we can represent our x-intercepts is we can say, okay, well, our first x-intercept is pi over 2. But then think about how often that repeats. Again, it repeats every 1 pi. So we could just say pi over 2 plus n pi. Again, understanding that n is an integer. All right, so you guys, those are the parent functions. So now what we're going to get into is transforming these graphs. And, we're basically applying the same transformations that we've learned in the past using a, b, h, and k to transform the graph. But with our trig functions, especially sine and cosine, we have different names for the transformations. And it really just is because of the nature of these graphs. Okay, so I'm going to switch now back to another gizmo where we can look to see what effect A, B, H, and K have. All right, here we go. All right, so let me launch the gizmo. And okay, so notice here we have y equals a times sine of b times x minus h plus k. All right, so you guys, in the past, when we learned our transformations, remember a vertically stretches or compresses the graph, and if a is negative, it reflects the graph over the x-axis. Now, a is going to have the same effect on the graph of sine or cosine, but I want you to notice what happens. So remember, if a is greater than 1, then the graph is vertically stretched. So notice what happens when we vertically stretch this graph. And let's say I stop with a equaling 4. So hopefully you notice that instead of the graph going from -1 to 1, the graph now goes from -4 to 4. So a affects the range. It doesn't, the domain is all real numbers, so it's not going to affect the domain. But a will affect the range. Now, we actually refer to a, in this case, as the amplitude, okay? So we learned that the amplitude of the graph of sine or cosine is the absolute value of a. Here we go. Okay, now why? Why do we call it the amplitude? Well, think of sound waves. So sound waves can be modeled by sine or cosine. And so you can think of as a gets bigger, we're turning up the volume. And as a gets smaller, we are turning down the volume. Now, if a is between, 0 and 1, which means it's a vertical compression by a, again, you can just see that the graph is vertically compressed. But again, the amplitude, like in this case, let's say I make it an easier value, like 0.5, then again, if you look at the graph, the range is now from negative 0.5 to positive 0.5, okay? And if a is negative, you'll see that the graph flips over the x-axis. So hopefully you can see that vertical reflection or flip. All right, so let's set a back to 1 so it's not having an effect on the graph. And let's talk about b. So in the past, we've learned that b is a horizontal stretch or compression, and if b is negative, the graph is reflected over the y-axis. All right, so right now b is set at 1, which means it's not having any effect on the graph. So let's see what happens as b gets greater than 1. Well, hopefully you're seeing a horizontal compression. Now, again, if you think back to these graphs modeling sound waves, what would be changing here is the frequency, okay? So often we might refer to B as changing the frequency. What it is also doing, though, is changing the period of the graph, okay? Now, let's say if we take B back to 1, which means it's not having any effect on the graph, and so what happens when B is between 0 and 1? Well, now it's just a vertical stretch. Excuse me, a horizontal stretch. But again, notice that the period is changing, okay? So let me show you that again. And then also, if B is negative, the graph does reflect, it just flips over the y-axis. Okay, so let's set B back to 1. And let's go back to our notes. Okay, so the period basically is going to be affected by the value of B. So for instance, like instead of, let's say, graphing one period from 0 to 2 pi, we might be graphing one period from 0 to pi. Or we might be graphing one period from 0 to 4 pi. Okay, so B is going to change your period. So how do we find the new period? All we have to do is take the period of the parent function, which is 2 pi, and divide it by B. And again, this is also sometimes referred to as the frequency. Okay, let's go back to the gizmo. Now, H. In the past, we've learned that H shifts the graph left or right. That is the same with sine and cosine. We just give it a new name. We call it a phase shift, okay? But it works the same way it has in the past. If H is positive, well, let's see if I can get this to move. Okay, well, let's see. Let me just type in some values here. So let's say H equals 2. Now it's finally moving. Okay, so here, H is 0, which is not having any effect on the graph. So if we move H, hopefully this isn't working the best that I wanted it to, but basically it is going to shift the graph left or right. Let me see if I can figure out what's happening here. Let me go back to select. Okay, I think maybe you can kind of see it moving left or right, hopefully. But anyway, H basically is what we call the phase shift. And so your phase shift, which moves the graph left or right, is H. But you guys remember, H can be a little tricky because in the equation, it's x minus H. Okay, so remember, if H is positive, the graph does go right, but the equation would be x minus H. Okay, and if H is negative, then the equation becomes x plus H, which means the graph goes left. Okay. All right, now, K shifts the graph up or down. And we do still call this a vertical shift with the graphs of sine and cosine, but the vertical shift can also identify what we call the midline, okay? The midline for the parent graph is the x-axis, because if you notice, the x-axis goes right through the middle of the graph. And then if you think of your amplitude, when you use your amplitude basically to graph the function, you're just going to go up however many points your amplitude is, and then down however many points your amplitude is. So like the graph is going to go above the midline based on the amplitude and below the midline based on the amplitude. Now, if we shift the graph up or down based on K, and remember K is very straightforward. If it's positive, the graph goes up. If it's negative, the graph goes down. Your midline is also going to shift. So you can always identify your midline based on K. So we can say that the midline is y equals K. And I'm just making it an equation because it is a horizontal line. Okay, so y equals K is the equation of a horizontal line. All right, so you guys, these are the main things that you have to remember. Your amplitude is the absolute value of A. Your period is 2 pi divided by B. Your phase shift is H. And then your midline is y equals K. All right, and then with that information, we will be able to sketch the graph. Okay, so these are some steps that can help you when you're trying to graph what we call sinusoidal functions. So the steps are 1, you find the amplitude, 2, you find the period, 3, you find the phase shift. And we just went over how to find those things. Now, when you sketch your graph, you start with the x-axis. And to label the x-axis, you always want or need 5 tick marks, okay, or 5 points. Your starting point is going to be your phase shift. The stopping point is going to be the phase shift plus the period. Now, to label the points in between, you just continually find the midpoint. To label your y-axis, you're going to refer to the amplitude. And once you have your x and your y-axis labeled, then you just sketch either sine or cosine. If the graph has a vertical shift, then you would want to sketch in your midline before you start sketching your graph. Okay, so let me show you some examples, and I think it'll be easier to understand. So here our function is y equals 4 times sine of 1/4 x plus pi over 8. Now, you guys, one of the first things I'm going to do is factor out b, because let me show you that back here, b is actually factored out. Okay, so we want to make sure it's written like this. Okay, so if I factor out 1/4, I'm just going to rewrite this as y equals 4 times sine of 1/4 times x. Now, if I factor a 1/4 out from the pi over 8, remember to figure out what's left, you divide. So like if I took pi over 8 and I divide it by 1/4, which means I would multiply by the reciprocal, which would be 4 over 1, and then let's say I cross reduce, that's actually going to end up equaling pi over 2. So this will become x plus pi over 2 in parentheses. Okay, let me get rid of these extra lines I put in there. Okay, so now we have this written the way we want it to, the way we need it to identify everything. All right, so let's start by identifying the amplitude. So your amplitude is easy. It's the absolute value of A. A is 4. Absolute value of 4 is 4. Okay, let's find the period. The period is going to be 2 pi divided by B. B is 1/4. So if we take 2 pi and divide it by 1/4, we'll change it to multiplying by the reciprocal, which the reciprocal of 1/4 is 4 over 1, which of course we can drop the 1. And so that'll end up equaling 8 pi. Okay, and then your phase shift, which remember is H, Now, see how we have a plus in our equation? That means h is actually negative pi over 2. All right, and we do not have a vertical shift for this graph. So, basically we know our midline is not moving. It's still the x-axis, or y equals 0. Okay. All right, so to put all of this into a sketch, we're going to start by drawing our x-axis. And actually, let me see if I can use the shapes they have on here. So let me just give myself an x-axis, and then I'm going to label 5 tick marks. 1, you just try to evenly space them. 2, 3, 4, 5. And to label those 5 tick marks, your first tick mark or point is going to be your phase shift. So this first one I know is negative pi over 2. Okay, the last one, because remember, we're trying to sketch one period of this graph. So we're going to take our phase shift, which is negative pi over 2, and we're going to add the period, which was 8 pi. Now we're going to need a common denominator because we're adding fractions. So I'll convert the 8 pi to 16 pi over 2. And then negative pi plus 16 pi gives us 15 pi over 2. So that is our last tick mark. To find the middle, and usually I just require my students to label 3 of the points or tick marks. So to label the middle, we basically are finding the midpoint between negative pi over 2 and 15 pi over 2. So to do that, we would, after I get this stuff to erase, we would add negative pi over 2 plus 15 pi over 2, which will give us 14 pi over 2. So negative pi over 2 plus 15 pi over 2 is going to equal 14 pi over 2. But then divided by 2, which is the same as multiplying by a half. So that'll end up equaling 14 pi over 4. And then, of course, we could reduce that to 7 pi over 2. So our middle point is going to be 7 pi over 2. Okay, and again, to find the middle, you just add the 2 endpoints and divide by 2. Okay, you guys, we're getting there. Now, to represent our amplitude, I'm just going to put in a vertical axis here. And so to label our y-axis, we just have to use our amplitude. So remember, the amplitude, since it's a 4, is going to turn up the volume, and instead of the graph or the range being -1 to 1, it's now going to be -4 to 4. Let's put that down here. All right, then we're just going to graph sine, because that's the function that we're trying to graph. And so to graph sine, I always remember that sine starts on the x-axis, okay? But remember, we're starting at our first point or tick mark. Okay, so our one period of sine would look like this. Here's our first point, second point, third point, fourth point, fifth point. So I kind of remember when I'm graphing sine that I always start on the x-axis or on the midline, okay, if there's a vertical shift, and then you go up, down, up with your points, and then you can just fill in the curve. And so this is one period of this function. Okay, let's look at a cosine graph. All right, so again, the first thing I'm going to have to do is factor out b, because I'm noticing it's not factored out. So if I do that, I'm going to get 1/2 times cosine of 4 times x minus pi over 4 plus 2. Okay, so let's start by finding our amplitude. So again, the amplitude is the absolute value of A. That would be the absolute value of 1/2, which is 1/2. The period is going to be 2 pi divided by B, and B is 4. So 2 pi over 4 is going to simplify to pi over 2. And then our phase shift, which is h, but notice here h is positive, is pi over 4. And our vertical shift is up 2, which is going to move our midline up 2, making it y equals 2 now. Okay, I think we have everything we need to sketch our graph. So again, we're going to start with the x-axis. And we're going to add, you always need 5 points. So 1, 2, 3, 4, 5. And again, just try to evenly space them out. Okay, to label our 5 points, the first one is your phase shift. So that's pi over 4. The last one is the phase shift plus the period. So if we add pi over 4 plus pi over 2, needing a common denominator, we'll convert the pi over 2 to 2 pi over 4. And then add your numerator. 1 pi plus 2 pi gives us 3 pi over 4. Okay, to find your middle, you add your two endpoints. So 1 pi over 4 plus 3 pi over 4 is 4 pi over 4, which simplifies to pi, but then divided by 2 gives us pi over 2. Okay, now I'm just going to add in a y-axis, and we're going to label the y-axis according to our amplitude. And our amplitude was 1/2. So we know, oh, actually, let me not label the y-axis yet, because this graph, remember, has a vertical shift. So let me put a few more tick marks here on my y-axis. And I think for my y-axis, even though the amplitude is 1/2, just to show you the midline, I'm going to label these counting by 1. So this would be -1 and -2. Okay, so you guys, here's our midline. The midline is going to end up at y equals 2. So I'm just going to make that dashed, okay? Okay, now I think we're ready to sketch our graph. So we're sketching the graph of cosine. So remember, cosine actually starts up. It doesn't start on the midline, okay? And because our amplitude is 1/2, since the midline is at 2, my first point would be at 2 1/2. So I'm just going to put it in the middle between 2 and 3. Okay, then cosine goes to the midline. Then it'll drop down 1/2 below the midline. Then it'll go back to the midline. And then it'll go back to 1/2 above the midline. So when I'm graphing cosine, I always know to start up and then go down, down, up, up. Okay, and then we're just going to draw the wave connecting the points. So this would be our graph of cosine, which again would represent one period for this graph. Of course, this is what's going to repeat over and over. All right, so you guys, that's how you graph these functions and apply the transformations. But let's kind of switch things around now. So let's say you're given the graph of a function and you are asked to write the equation. Okay, so all we're going to do, like, again, we just got to find a, b, h, and k, and then we can write the equation. So remember that, the form of our equation here is y equals a times sine, of course that could also be cosine, of b times x minus h plus k. So from the graph, we just got to be able to find a, b, h, and k, and then we'll be able to plug them in and write the equation. So first thing I would do is try to, let's say from this graph, we want to write an equation using sine. So I would try to locate in this graph one period of sine. And I'm actually noticing that one period of sine is represented from 0 to pi. Okay, so focusing on that one period, I can see that my amplitude, or A, is equal to 1, okay, because, again, the graph is between -1 and 1, or the range is -1 to 1. So I know A is 1. Okay, to find B, remember, is going to change the period. So I'm noticing that this graph goes from 0 to pi, okay? Now remember, our rule to find the period, actually, let me erase this for just a minute. Okay, so remember, the way that we would always find B, or the way that we would find our new period, is always to take 2 pi and divide it by B. Okay, so looking at the graph, we know that 2 pi over B actually equals 1 pi, because that one period is sketched from 0 to pi, making the period in the graph 1 pi. So I could use this equation to solve for B. So let's say that I multiply by B on both sides. I get 2 pi equals B times pi. And then honestly, because we have pi on both sides, they're just going to simplify out. So from that, we know that B equals 2. Okay, now I'm also noticing, I'm thinking about H now, that the graph starts at 0. Okay, so H, I know, is equal to 0 because that's my starting point. And K, I can also tell, equals 0 because the graph is not shifted up or down, and I know that based on the midline. Okay, the midline is still y equals 0. All right, so I have everything I need to write my equation. I have y equals 1, okay, you don't have to write the 1, times sine of 2 times x plus 0. Of course, you don't have to write the plus 0. So this basically is y equals sine of 2x. Okay, now I wanted to show you that we could also write an equation for cosine for this graph if we wanted to. And so if I were writing, we could write an equation for cosine based on this graph if we wanted to. So if I were writing the equation for cosine, I would look at the graph and try to locate one period of cosine. And so I'm seeing that one period right here. And so this would be from pi over 4 to 5 pi over 4. Okay, so let's just say, okay, just because I don't have room, I'm going to try to erase this, which is going to take forever. Okay, so if I'm writing the equation for cosine, Bear with me. Okay, if I'm writing the equation for cosine, then my generic equation is going to be y equals a times cosine of b times x minus h plus k. Okay, so a lot of the things, basically are staying the same. Like in this case, a is still equal to 1, k is still equal to 0. The period would still be the same, but let's just say that, to give us more practice, that we found the period. So in this case, because the graph that I'm looking at would be from pi over 2 to 5, or excuse me, pi over 4 to 5 pi over 4, if I take the 5 pi over 4 and subtract pi over 4, I'm going to get 4 pi over 4, which equals pi. Okay, so then that again was telling me that 2 pi over b equals pi, and then you solve for b, and we're going to get b equals 2 again. But I just wanted to show you that if the graph doesn't start at 0, so here our one period of cosine starts at pi over 4, that you could take where the graph starts and where it stops, and you subtract. That would represent the period. You set that equal to 2 pi over b and then solve for b. Okay. Now, this time the graph is actually shifted to the right. So h would actually equal pi over 4, which was a little different when we were writing the equation for sine. Okay, so we have everything we need to write our equation. So, sorry, this is a little messy. The equation would be y equals 1 times cosine of 2 times x minus pi over 4 plus 0. Okay, so a couple things I was trying to show you there is, given that one graph, we were able to write an equation for sine, and we were able to write an equation for cosine. Obviously, the equations were a little bit different, but also to write the equation, all we had to do is look at the graph and determine a, b, h, and k, and then plug them in to write the equation. Okay, you guys, I know this is probably becoming a pretty long video, but I just have one more example because I just wanted to show you one example where the midline is not 0. And so in this case, if I'm looking at this graph, and let's say that we want to write an equation using cosine, okay? So I already know, my generic setup is y equals a times cosine of b times x minus h plus k. But I'm noticing this time the graph is actually shifted, and it appears to be shifted down. And so all you have to do is try to locate the middle of the graph, and it looks like the middle or the midline would be y equals -2. Okay, so that tells me, because my midline is y equals -2, that k equals -2. All right, now the amplitude, if you notice, the graph goes 4 units above the midline and 4 units below the midline. So A equals 4. Okay, to find B, now here's one period of cosine. And so that period is going from 0 to pi over 2, which actually tells me that h is 0 because my starting point is 0. But to find B, okay, technically what I'm doing is taking pi over 2, subtracting 0, okay, which is pi over 2. We know that 2 pi over b is going to equal pi over 2. So to solve this, you guys, I would look at this as a proportion and cross multiply. So if I were to cross multiply, do the little butterfly, I would get 4 pi equals b times pi. The pi's are actually going to cancel or technically simplify to equal 1. But anyway, we end up with b equaling 4. Okay, so we have our a, b, h, and k, so we can write our equation. Our final equation would be y equals 4 times cosine of 4, well, times x, you probably didn't need the other set of parentheses there, minus 2. Since h was 0, you could always write x minus 0 if you want to, but you really didn't have to. And I really didn't need the second set of parentheses. I could have just written this as y equals 4 times cosine of 4x minus 2. All right, you guys. So that concludes our video on graphs of sine and cosine. We'll definitely practice this some more in class. As always, thank you for watching and have a good night.